Almost every day, I'm asked this question in different shapes and forms. So we want to actually work in this area of data science, machine learning, AI. What should we do? Should we study data science? Should we study machine learning? Should we study AI? Should we take a course in data science and machine learning? Should we take a course in machine learning and AI? Should we take a course in data science and AI? Now, what do these terms really mean? What's behind these terms? Are they exactly the same? How similar are they? Are they different? So given that I'm asked this question sort of almost every day, I thought I might as well sort of make a video about what is really going on behind the scenes. What's going on behind these terms? One way to think about it is three different layers. There's a computing layer, there's a mathematics layer, and there is a computing plus mathematics plus data layer. These are your three foundational layers. So if you're thinking in terms of a house, you can think of this as a three-storied house. Computing plus mathematics plus data. Now clearly, you can't make the third floor of the house without first making the first floor and the second floor. In fact, the third floor in this particular case is a combination of the first two floors. So the math plus computing plus data layer is a combination of the math layer and the computing layer. Now let's break up these different layers and see what's going on inside these different layers. So if you look at the computing layer, then that has four sort of boxes in it. There's programming, which these days is mainly Python. There's algorithms, there's data structures, and databases. These are four essential ingredients. Now, if you look at the mathematics layer, that layer again has four essential ingredients: probability, statistics, linear algebra, and optimization. So that's the math layer. Now, when you combine the computing layer and the math layer with data, you get four new boxes: supervised learning, unsupervised learning, reinforcement learning, and generative AI. So essentially, these three layers then break up into these 12 boxes. These 12 boxes are essentially known as the data science and AI stack. Sometimes a short form is used and they call it the DA stack. But essentially, this is what these three layers break up into. These are the 12 boxes you should be familiar with. So one question that I'm asked again very, very frequently is, given that there is a computing component, given that there is a mathematics component, what should we study as a degree? Should we study computer science? Should we study mathematics? Or should we study engineering? In fact, the interesting thing is that this area known as the sort of data science and AI stack actually sits in the intersection of all of these three different domains. There is a mathematics component to it, there is a computer science component to it, and there's also an engineering component to it. And the DA stack, in terms of the skill set and the mindset, actually sits bang in the center of this intersection. What's the sort of mindset or the sort of philosophy set that one should have if one wants to be successful in this area of sort of data science, machine learning, and AI? Now, we've got a point of view. Our point of view is that if you have the ability to think like a mathematician, act like a computer scientist, and reason like an engineer, you'll do really, really well. Now, if you think about it, in engineering domain, the words that you often hear are design and trade-offs. When you talk to mathematicians, the words that you often hear are elegance and simplicity. And when you talk to computer scientists, the words that you often hear are build and scalability. So if you're able to combine all of these in terms of a three-layer philosophy, then we think you'd actually be very well positioned to be very successful in this broad area of data science, machine learning, and AI.